Hello student, welcome to the online physics classes. Today we are going to start a new chapter which is electric field. Electric field. So before starting this chapter, let me recall some basic thing which we have discussed in previous classes. When we want to shift a chair from one location to another, we apply a force on it. In this case, we have a direct contact with the chair. Such a force is called a contact force. But if we drop a pen from some height, it starts moving down due to the attraction of earth. In this case, the earth and the pen are not in direct contact. Such a force is called a non-contact force. So, first topic in this chapter which is going to adopt is electric field. Suppose there is a charge Q and around this charge there will be some space in which influence of this charge can be experienced, and that region in which influence of this charge can be experienced is known as electric field. Okay. Means space around a charge in which electrostatic influence can be felt is called electrostatic field. And this field strength can be measured electric field intensity or field strength. Suppose this boundary or this region is an electric field and a charge Q. This one is known as source charge. Suppose we have to find what will be the electric field intensity or what will be the strength of electric field produced by this charge at point P. So simply we have to place a test charge Q naught at this point. So suppose magnitude of this charge is Q naught and nature is positive. So this plus Q and this plus Q naught, there will be a force of repulsion. So let's consider force of repulsion between these two is F. So electric field intensity at this point P is defined as force of attraction or repulsion between these two charges, that is F, divided by magnitude of test charge Q naught. So ratio of these two quantity is known as electric field intensity at this point P, and electric field, which is a vector quantity. So if we put an arrow on E, and force is also a vector quantity. So direction of this electric field, direction of electric field E will be same as force. So now unit of this electric field E is equal to F upon Q naught. This force can be measured in terms of Newton, and charge can be measured in terms of Coulomb. So Newton per Coulomb will be SI unit of electric field. Now dimension of this electric field E is equal to F upon Q naught. So dimension of E is equal to dimension of F, which is a force. Dimension of force will be M L T minus 2, and dimension of charge will be A T. So E is equal to M L A minus 1 T minus 3. So dimension of electric field will be M L A minus 1 T minus 3. And representation of this electric field representation of this electric field can be represented as, if we have a positive charge, so direction of electric field will be always outward. If there is a negative charge, so due to this negative charge, direction of electric field will be always towards the charge, means towards the negative charge. Okay. So now there are two types of electric fields. First, uniform electric field and non-uniform electric field. Uniform electric field is said to be, or an uniform or an electric field is said to be a uniform in a certain region if both the direction and magnitude of electric field are same as that all points there. And in non-uniform electric field, either the direction or the magnitude or both vary from point to point. Means uniform electric field can be represented by parallel lines, and non-uniform electric field can be represented by variable, like this one. So these lines represent non-uniform electric field, and these parallel lines represent uniform electric field. So now we are going to find expression for electric field due to a point charge. So we are going to find expression for electric field due to a point charge. So let's consider Cartesian coordinate. x-axis, y-axis and z-axis, and this O is the origin. If we place a test charge, if we place a source charge at origin Q, and we have to find electric field intensity at point P, which is r distance away from this source charge. So at P point we have to place a test charge. Let's consider that test charge is Q naught. So direction of this electric field will be always because we have taken a positive source charge. So electric field intensity, direction of this electric field will be outward, E. So from the Coulomb's law, there will be a force of repulsion between this charge Q and this Q naught. So according to Coulomb's law, force between these two charged particles will be equal to F is equal to 1 upon 4 pi epsilon naught, first charge Q and second charge Q naught upon distance r square. In terms of vector, it can be written as like this one, equation number 1. And according to definition of electric field intensity, according to definition of electric field intensity, electric field intensity at any point is defined as ratio of force between source charge and test charge, which is F, upon magnitude of test charge Q naught, equation number 2. Now if we put value of this force from equation number 1 into equation number 2, so from equation 1 and 2, electric field E is equal to 1 upon Q naught, and this F, which is equal to 1 upon 4 pi epsilon naught Q naught by r square into r cap. So this Q naught will be cancelled out. E is equal to 1 upon 4 pi epsilon naught Q by r square into r cap, which is required expression.